Welcome to Idea Mechanics. You know that feeling, right? When your software just gets slower and slower, completely bloated and suffocating over time? What if I told you there's a system to prevent that? A system for inventive problem solving called TRIZ. And today, our lead expert, the Navigator, is here to guide us in building digital systems that are aggressive, self-cleaning, right from the very start. If you're ready to stop relying on luck and start mastering systematic discovery, go on, hit that subscribe button to join the Idea Mechanics team. And don't forget to ring the notification bell so you're the first to see our next innovation breakdown. We want to build this culture with you, so drop a comment below and tell us which TRIZ principle or tech challenge we should tackle next. Okay, let's dive right in. Now, before we get into any of the cool tools, we have to start with our thinking. As innovators, we have got to break free from this trap of digital hoarding. And this isn't just a small tweak, you know? It's a huge, fundamental shift in how we think about building software that actually lasts and performs well. This slide just says it all, doesn't it? The old way is all about reacting. We wait for a server to crash, for something to break, and then we rush in to put out the fire. Honestly, it's a system built on hope. But the new way, now that's proactive. It's about systematic discovery, designing intelligent systems from day one that know how to manage themselves. And that brings us to the core question that drives this entire approach. You see, instead of asking, how can I fix this by hand? A TRIZ innovator asks, how can the system fix itself? Just framing the problem this way, giving the system the power to be self-sufficient, that's the key that unlocks these really elegant, really robust solutions. So our first answer to that question comes from TRIZ Principle 34. The Navigator is pointing us to our first tool now, showing us how this principle lets us design software that is, for all intents and purposes, self-healing. This is where we stop talking theory and start executing people. The main idea here is really simple, but it is so profound. Once any little piece of data or component has done its job, it should be automatically thrown away. You just don't let old, useless things hang around and slow everything down. Principle 34 is all about engineering a constant, built-in cycle of renewal. All right, let's see how this works in the real world with a fantastic example. The Navigator is highlighting one of the most famous uses of Principle 34 in software history, Java's garbage collection. We like to call it the digital custodian, and for a very, very good reason. So instead of making a human programmer track every single piece of memory, which is, let's be honest, a recipe for mistakes, the Java Virtual Machine, or JVM, does it all automatically. It's constantly scanning for bits of memory or objects that the application isn't using anymore. As soon as it finds them, it systematically gets rid of them and reclaims that memory. This one automated process completely prevents memory leaks and just wipes out a whole category of bugs. It's brilliant. Now, this principle isn't just for managing memory. Oh no. It's also absolutely critical for reliable communication across messy, unreliable networks. Let's take a look at how data gets from point A to point B, using what we call the boomerang packet idea, which is at the heart of TCP/IP. And this is just a perfect illustration of the principle. A network can't just sit around and wait forever for a data packet that might have gotten lost. That would freeze the entire internet. So instead, it starts a timer. If it doesn't hear back, it assumes something went wrong. And the key is what it does next. It aggressively discards that failed attempt and recovers by sending a brand new packet. It doesn't hope for the best. It systematically guarantees delivery. Okay, so Principle 34 gives us this nice, continuous, self-healing cycle. It's very elegant. But what about all that digital junk? You know, the old log files, the temporary data that just builds up over time no matter what. For that, the Navigator is showing us we need something a little stronger. And that brings us to Principle 38, what we call the digital acid. I love this quote. It just perfectly captures the shift in thinking. We are not talking about a bit of late spring cleaning here. This is about deploying a powerful, targeted solution that is designed to completely dissolve digital waste. It's about treating cleanup as a core aggressive function of the system itself. So what is a strong oxidant in the software world? Well, think of it like a specialized algorithm, a digital chemical that's engineered for just one thing, to hunt down and completely destroy the junk that's choking our systems. This is the code that goes in and purges old logs, clears out temporary caches, and deletes forgotten data that has no more purpose. And the results? Well, they speak for themselves. Look at this. A system that's just crippled by junk files might be running at, 35% of its potential? But after you run a digital acid sweep, boom, performance skyrockets. That's the difference between a system that's slowly dying and one that's always running at its peak. So, we've looked at two incredibly powerful principles. But the real magic, the true stroke of architectural genius, happens when you bring them together. This is where we combine everything the Navigator has shown us to build something that is genuinely resilient. Let's break down this synergy, right? Principle 34 gives you that continuous, real-time self-healing. It's like the system's immune response, always fighting off the small stuff. Then Principle 38 comes in with the periodic, aggressive deep clean, a powerful purge that gets rid of all the accumulated toxins. When you put them together, you create a system that isn't just efficient, it's incredibly robust. And this is the most crucial point, the big takeaway for every single innovator watching right now. It's this: we have to fundamentally change our relationship with data. The sign of brilliant software isn't just how well it handles new information, it's how ruthlessly efficient it is at destroying old information. That is the mindset shift. And so that leaves us with one final question for you to take back to your own work. In your projects, in your systems, even in your digital life, what junk have you allowed to build up? What part of your architecture doesn't just need a gentle tidy up, but needs a truly aggressive solution? Let us know what you think in the comments. Let's keep building this culture of innovation together.